All right, so this next section is solving quadratics by square roots. If you have the quadratic in the form of ax squared plus c equal to 0, you can actually solve this using square roots. Yep. Okay, so the steps for this is that first you have to isolate x squared, and then we're going to take the square root. Of both sides, because what you do to one side of the equation, you have to do to the other side of the equation as well. So before we get into that, I just want to remind y'all that if you have a number, say you have a positive 6 and you square that, you're going to get 36. Well, if you square a negative 6, you're still going to get 36. Now, if you put this in your calculator, you got a negative 36. Guess what? You did that wrong because you did not put that negative 6 in parentheses. When you square a negative number, it has to be in parentheses in your calculator. So when we're going to take the square roots of things, you're going to get a positive, you're going to get two square roots. A positive number always has two square roots because there's two different ways you can get to 36 squaring a number. You can get to it by squaring the positive version of itself or the negative version of itself. So let's take a look at some examples. So for example, let's start with number 1, which state that x squared minus 16 equals 0. Actually, this bright green. So like it said, your first step is to isolate your x squared. In this case, we're going to be able to do that by adding by 16 on both sides. This is going to give you x squared equals a positive 16. Then you take the square root of both sides. The square root of x squared is x. Remember, when you take the square root of a positive number, you're going to get plus or minus its square root, which is 4. So then the way we would write this would be x equals open curly brackets negative 4 comma 4. And that would be our answer. All right, we might have something along the lines of, let's look at number 12, which is 1/2 x squared plus 3 equals 75. So following the rules are 2 steps. We subtract by 3 on both sides. You get 1/2 x squared equals 72. And then to get rid of the fraction, you would multiply by 2 on both sides because you want to do the reciprocal, and this is technically 2 over 1. The reciprocal of 1/2, and then you just flip it. So then you're going to get that x squared equals, well, 72 times 2 is going to give you 144. So then you square root both sides, you would get x equals plus or minus 12, or x equals negative 12 comma 12. Did you want the negative version of 12 or you want the positive version of 12? And that would be our answer. All right, suppose we have, you can also get fractions in this, that's totally fine as well. But let's say that we're getting some irrationals. So you can get irrational solutions. So for example, we're going to take 21, which says 2x squared minus 126 equals 0. Well, solving for isolating x squared, you would go add 126, add 126. So then 2x squared equals 126. And then divide by 2, divide by 2. So x squared equals 63. Then you take the square root of both sides, and you would get x If you tried to take the square root of 63 in your calculator, you would actually get an irrational number. You would get a never-ending decimal with no pattern, no repeating pattern. So you would actually just have plus or minus the square root of 63, which is a total legit thing you can have because, okay, if you take the square root, I did not mean to hit that, stop that. Okay. If you take the square root of 63, and that outside, and square that, you get 63. If you get the square root, if you take the square root of a negative, if you take the negative square root of 63 with the negative outside the 63 and square that, you get 63 again, which is what we wanted. If you take your roots right here and you square them, you should get 16 back up here, and in this case, we would get 63 back. All right, once you have that, double check. Make sure your number is as reduced as you can go because your instructions are going to tell you to simplify all irrational solutions. That means that they want you to write them all in simplest radical form with, if you have, okay, let's look at 63, the square root of 63. If you can find the biggest perfect square that goes into 63, which in this case it would be 9 because 9 times 7 is 63, you can take the square root of 9. Well, this would be square root of 9 times the square root of 7. Well, that's 3 square roots of 7. So then you're going to rewrite the square root of 63 as plus or minus 3 square roots of 7, and it's perfectly the exact same thing. And so then that would be x equals, open curly brackets, negative 3 square roots of 7 and 3 square roots of 7. And there you go. All right, now, for example, let's take number 23, which has negative x squared minus 10 equals 18. Well, again, isolate that by adding by 10 on both sides. Then you would get negative x squared equals 28. Okay, well, your x squared still is not isolated because you have a negative 1 times it. So then you can divide by negative 1 on both sides. You can multiply by negative 1 on both sides. Either of the two is going to give you x squared equals negative 28. Okay, then next thing we do is take the square root of both sides. Well, you would get x here. If you try to take the square root of a negative number inside your calculator, it would give you back, the error it would give you is actually square root of negative 28. Error, non-real answers. That means that you're going to get imaginary numbers as your answers, and we do not work with imaginary numbers right now in Algebra 1. We will be working with them later on in your math career. So I'm not saying that you can't take the square root of a negative number, because you can, but what I'm saying is that we will not be taking the square root of a negative number right this minute. So instead of that, we're going to write this as x equals no solution. And that's your answer. The reason you have to say that is because you're not going to have any real answers, and we're looking for real numbers.